Hello and welcome to Everything E.M, your YouTube channel for Cambridge Environmental Management. In these content videos, we work through the syllabus step by step and make sure that we cover absolutely everything without wasting unnecessary time. Here we go. In the previous lesson, we looked at how rocks form. In this lesson, we move on to how humans extract rocks, ores and minerals from the earth, and what impacts this can have on the people, the economy and the environment. Humans depend on rocks, ores and minerals for building roads, our technology, transport, energy systems and a huge amount of everyday products. But extracting them can damage landscapes and ecosystems, so environmental management is all about balancing those human needs with environmental protection. You can find the latest syllabus document on the Cambridge International website. I've put the link in the description for you, but you can pause the video so that you can see what we're covering today. Before we look at mining methods, we need to understand three important words: rock, mineral, and ore. A rock is a natural occurring solid material that forms as part of the Earth's crust. Rocks are usually made from one or more minerals. A mineral is a naturally occurring inorganic substance found in rocks. Minerals have a specific chemical composition. And an ore is a rock containing minerals and metals. In real life, we usually only mine ore if it contains enough useful mineral or metal to make extraction worthwhile. If the amount is too small or too expensive to extract, it may not be mined. Rocks, ores, and minerals are used to make many products such as steel for buildings and bridges, copper wiring for electricity, cement for construction, and minerals used in electronic components. There are three main categories of extraction in the syllabus. We have surface extraction, subsurface extraction, and biological extraction. Surface extraction is used when the rock or mineral deposit is close to the Earth's surface. The overburden, this is the soil and the unwanted rock above the deposit, is removed and large machines can then dig out the useful material. So you'll see the first one above has three names. It's open pit, open cast, or open cut mining. It's the same thing, and it involves digging a large open hole or pit to reach the resource. Strip mining removes long strips of overburden to expose a seam of material, which often this is what happens with coal extraction. Then we've got subsurface extraction. This is used when the deposit is too deep underground for surface mining. The deep mining and shaft mining involves digging vertical shafts and horizontal tunnels to reach the ore. The miners or the machines then extract the material underground and it's brought to the surface. This method can reach deeper deposits, but it's obviously more expensive and more dangerous than surface mining because of risks such as tunnel collapse, poisonous gases, and underground accidents. The third one, biological extraction. This is where we use living organisms to extract metals from low-grade ores or waste rock. Phytomining is where we use plants. The plants are simply grown in the soil containing the minerals, and they absorb the minerals through their roots. The plants can then be harvested and burned, and the metal can be extracted from the ash. Bioleaching uses microorganisms such as bacteria. The bacteria helps to break down the ores and release metals into a solution called the leachate. The metal can then can then be extracted from this solution. To mine or not to mine, that is the question. So how do companies decide on whether they are going to go ahead with extraction? First, they will be exploring, which means they will be searching for deposits and finding out whether useful minerals are present. Companies may use maps, satellite images, surveys, geophysical methods, and drilling samples. If exploration does not show a useful deposit, the mining will not go ahead. Geology means the type, structure, depth, and stability of the rock. This affects which mining method can be used. For instance, if the ore is close to the surface, surface mining could be possible, or if it's deep underground, shaft mining may be needed. If the rock is unstable, mining could be more dangerous and expensive. Accessibility and terrain. Accessibility means how easy it is to reach the site, whilst the terrain means the shape and difficulty of the land. Mining is easier if there are roads, railways, ports, electricity, and water nearby, and mining is harder and more expensive in remote mountains, deserts, forests, and areas with steep slopes. Quantity and quality of the deposit is always very important. Quantity means how much ore is present. Quality is how much useful metal or mineral is found in the rock. If it's a high-grade ore, it means it contains more useful material and it will be more profitable, where low-grade ore will contain less useful material, so it may not be worth extracting unless the prices are so high, or you can use biological extraction. Climate. Climate affects safety, working conditions, and costs. Heavy rainfall can flood open pits and increase erosion, and extreme heat can make working conditions dangerous. Very cold conditions may freeze equipment or slow transport. Dry climates may make dust control and water supply really tricky. Environmental impact assessments, or EIAs, are studies carried out before the mining starts. It predicts possible impacts on air, water, soil, the biodiversity in the area, the people living close by. It also suggests ways to reduce damage, such as controlling pollution, managing waste, and how to restore the land after mining. Supply and demand. This affects the price of the material. If the demand is high and supply is low, the prices rise, so mining becomes more profitable. But if demand falls or there's a lot of supply available, prices may drop and mining may no longer be worth the cost. Cost and profit. Finally, companies compare costs and profit. Costs include exploration, machinery, the workers, transport, energy, environmental protection, and the land restoration. Mining will usually only go ahead if the expected income is much greater than the total cost expected. So mining decisions are not based only on whether there's a resource. It depends on whether it can be found, reached, extracted safely, sold profitably, and managed responsibly. All right, let's look at the impacts of mining. Mining creates environmental costs, but it can also bring economic and social benefits. And in the exams, you could be asked to describe and explain these environmental, economic, and social impacts. So let's dig into them and see what they are. So under environmental impacts, There are quite a few that you can name, and I'm just going to talk through them very quickly. Loss of habitat and biodiversity is clearly a good one to start with, because when mining begins, they have to clear vegetation. This will then destroy the habitats, meaning plants and animals will lose their place to live, their place to feed and reproduce. And when habitats are destroyed, biodiversity decreases because fewer species can survive in the area. Mining creates a huge amount of air pollution through blasting, drilling, crushing, and transporting rock. Dust can cover the plant leaves, and this will reduce photosynthesis. And for humans, it can also cause breathing problems. Waste rock and tailings, which are like a rocky sludge waste, can cause land pollution because of the toxic substances in the soil that it can leave behind. This will stop plants from growing and make the land unsafe for farming or housing. If you have mining in the area, then you're going to have noise pollution due to the explosives, the drilling, the machinery, and the large trucks, all creating noise. This will disturb local wildlife, and it will also reduce the quality of life for the nearby communities. Visual pollution, because of those big open pits and large heaps of tailings and the large machinery and scarred landscapes. So your area will become damaged and unattractive, which will affect tourism and people's sense of belonging to a place. Water pollution is obviously a biggie because those chemicals, those metals, the acidic drainage from the mines can all into the rivers and the groundwater. This will harm aquatic organisms and animals and make water unsafe for humans and livestock. Some pollutants, especially heavy metals, can build up in organisms over time. This is called bioaccumulation. Very important for the exams, along with the next word, which is biomagnification. This is where the heavy metals are becoming more concentrated higher up the food chain. Water usage. While mines use large amounts of water for processing or for cooling machinery and for controlling dust. In dry areas, this can reduce water available for farming, for the local communities, and of course for the ecosystems. Waste management is a biggie because mining produces large amounts of waste, and these need to be stored safely. If a waste heap collapses or leak pollutants, it can cause long-term environmental damage. Let's look at economic impacts. Mining can, of course, create income for the local and the national economies. It provides jobs directly in the mine, but also indirectly through all the transport, the equipment supply, the construction, local shops and services needed for the miners. Governments can earn money through taxes, licenses, and exports, and mining can then increase the national income, especially if minerals are sold to other countries. However, mining can also make an economy dependent on one resource, and we have seen in the past that if mineral prices fall, mines may close, and that will have a massive impact on the area. Social impacts. Mining can affect people's lives in both positive and negative ways. So just very quickly, positive ways is obviously employment, incomes are improving. Mining companies may also build roads, electricity supply, they might build clinics and schools and water systems. All of these will have a wonderful impact for the local people. Negative is people may lose farmland, homes, or cultural sites if land is taken for mining. Communities may also experience more traffic, noise, dust pollution, and pressure on the housing and local services. So it's important for exams not just to explain the impact, not just to name the impact, but to explain it. So if, for example, don't only write down water pollution, rather say that chemicals or heavy metals can enter the rivers, harm aquatic organisms, and make water unsafe. So that way you can guarantee your marks. The syllabus asks us not to only describe the strategies, but also to discuss their benefits and limitations. That means that we need to be able to talk about both sides, so what works well and what doesn't. So let's first look at the benefits of repurposing and restoring mined land. Well, we will definitely have safer and more useful land. Again, restoration can make the damaged land safer by filling the holes, by stabilizing the slopes, reducing the risk of collapse and erosion. It will improve the appearance, less scarred by machines, more vegetation. By planting trees and by improving the soil, we'll also be allowing plants to grow again. And as plants return, insects, birds, and other animals might also return, which will increase the biodiversity. And repurposed land can become parks or lakes or walking trails or nature reserves or sport facilities, tourist attractions. These can all create new jobs after the mines close. What are limitations? Well, restoration will cost a huge amount of money because the land needs to be reshaped, the soil needs to be improved, the pollutants need to be treated, and the vegetation needs to be replanted. And natural recovery can take many, many years. A big issue could be that the pollutants are difficult to remove out of the area. Heavy metals or chemicals may remain in soil or groundwater even after there's been treatment for it, which will limit future land use. Some sites will just remain really unsafe as well because the deep pits or unstable ground or contaminated soil or polluted water may make the area unsuitable for housing or farming or recreation. And there will be long-term monitoring needed because restored land has to be monitored to check that there isn't any erosion, further pollution, slope failure, or issues with plant growth. Without maintenance, the site might just become damaged again. In an exam, a strong answer names the strategy and then explains how it helps and gives a realistic limitation. So you're giving your strategy, you're giving the pro, you're giving the con. For example, tree planting is naming the strategy. Tree planting reduces erosion because roots hold the soil together, but it can take many years for a stable ecosystem to develop. Let's finish by checking the key vocab. Bioaccumulation is the buildup of a substance, often a pollutant or toxin, inside one organism over time. Bioleaching is the biological extraction using microorganisms such as bacteria to help release metals from ores into a solution. Biomagnification is the increase in concentration of a substance at higher levels in a food chain or food web. An ore is the rock containing minerals and metals, and as we know, an ore is only mined if it contains enough useful materials to make the extraction worthwhile. Overburden is the layer of soil and rock that needs to be removed before you can mine, and phytomining is the biological extraction using plants. Plants absorb minerals from the soil, they're harvested and burned, and then the metal can be extracted from the ash. In this lesson, we looked at how rocks, ores, and minerals are extracted using surface, subsurface, and biological methods. We also looked at the factors that affect whether mining goes ahead, the environmental, economic, and social impacts of mining, and how damaged landscapes can be restored or repurposed. So well done. You have now completed topic 1.2, extraction of rocks, ores, and minerals. You can find the study notes, a worksheet, and flashcards for this topic on my website. The link is in the description below. And if you have any questions, please ask them in the comments. If not, I'll see you in the next lesson.